One person has joined, Vinit Joshi.
Yes, sir. We are live on YouTube.
Hmm.
You can start, and whenever the student posts a query on YouTube, I'll repost it here, sir.
Okay, fine.
Okay, sir.
Shall I start now?
Yes, sir. You can go ahead, sir.
Okay, thank you. Okay, good afternoon, everybody. And welcome to the live session of the NPTEL course, Machining Science, which is a 4-week course, as you have seen. 4-week course means per week it's a 2.5 hours. Okay. Now, I would say that this is a very short period for discussing the entire amount of, huge amount of machining science course. However, I tried my best to tell the basics of the machining science and the reasoning with the logic and all those things. So I hope it will be clear to you. However, today's session is, the purpose of today's session is to clarify any doubt that you have, if you have any doubt, okay? And some clarification that you need from the lecture material, okay? So before that, I would like to briefly discuss the material that we discussed during the lecture hours, okay? The 10 hours of lectures in the video mode. So as I said, this course content is huge, okay? Like at IIT-Kanpur, we covered that for 42 hours, okay? In a semester, there's 42 hours. And you can see that in 10 hours, that 42 hours material had to be covered. So, however, as you have seen that I was not in hurry, very slowly, very in details. I explained all those things because fortunately it was not a blackboard and chalk system. It was through slides. So the time, we had some time in explaining through that slides. Okay. So initially what we have in machining science, what we have discussed is the basics, advantages, what are the manufacturing operations, okay? What is the definition of machining? And then the basic of machining, where the plastic deformation occurs, that basic comes from the tensile test of a mild steel bar. So why mild steel bar I discussed? Because, many of the materials that are used in the engineering field, these are the basically not the brittle materials, okay, but the ductile materials like mild steel. So in case of mild steel, the stress strain curve or the load extension curve we have discussed in details that goes through different stages like elastic limit, plastic limit, like necking point, okay, fracture, and when the plastic deformation takes place, after that the fracture happens. Now, each region is explained in great details that why this happens and when this happens. After that, the stress strain like engineering stress, nominal stress, engineering strain, etc. Those are discussed. Then we came to the mechanism of plastic deformation. Okay. Here, through the atomic scale, I tried to explain that what happens in the infrastructure or in the crystallographic structure of the material, so that the plastic deformation takes place. How much shear stress involved for deforming the material, and what happens when the deformation takes place. Okay, that is what is the mechanism of plastic deformation. Here we said that there are certain defects in the crystallographic structure, and those defects actually help us in deforming the material, meaning the less stress is required for deforming the materials because of those defects. And how it happens, that I also explained in details. Next, we came to basic machining parameters like speed, feed, depth of cut, and their relationships between them. Okay, and when the chip is formed, during the chip formation, like what is the relationship between the uncut thickness and the feed, or the width and the depth of cut, okay, through the tool angles. All right. Then we said that there are two basic types of the cutting processes. One is the orthogonal cutting and another is the oblique cutting. And the difference between them is that the angle between the cutting edge and the cutting velocity vector. So when the cutting edge is absolutely perpendicular to the cutting velocity vector, it is the orthogonal cutting. And if it is inclined to a certain angle, it's the oblique cutting. Okay. However, we said that basically the practical machining operations, all the operations are of the oblique cutting type. And this is simply because during the oblique cutting, since the tool is inclined, so the tool strength obtained during the cutting will be more. All right. However, there are few cutting processes which are the examples of the orthogonal cutting, like the cutting process when we have the tool at a 90-degree. For example, you are reducing the length of a pipe, okay, through the facing. So that would be with a tool which will be perpendicular to the axis of the workpiece, and that can be considered as the orthogonal cutting. Okay, afterwards we discussed the types of chips. We said that there are continuous chips, there are discontinuous chips, and there are continuous chips with a built-up edge. Then I explained the mechanism of the built-up edge formation, why the built-up edge forms, and what are the advantages and disadvantages of the built-up edge. Basically, we have said that built-up edge is not good for us, okay? Because built-up edge, what happens is it destroys the tool geometry, okay? Meaning that there won't be any definite rake angle or flank angle, which are important for the power consumption and the force. Because every time the built-up edge forms, it changes its angle. Okay. So during the cutting process, the angle keep on changing. Therefore, the power consumption and the force will keep on changing. So therefore, it's a disadvantage for us. Only advantage probably that the built-up edge is strong. The hardness of the built-up edge material is stronger than the hardness of the tool material. And therefore, while cutting, the tool wear will be less because the cutting process will go through the built-up edge material and not the tool material. Okay. Then we started discussing the tool nomenclature. That means the angles of the tool. And we said that there are basically the three types of the systems where the tool nomenclature is defined. One is the coordinate system. This is also called the American system. Another is the orthogonal rake system, or this is called the continental system. And the third one is the international or the normal rake system. So we said that in three different systems, the angles are different. However, you can convert angles from one system to another system. And that's not a difficult job. It's a geometry, and that geometry we have discussed in details. Then we said about the selection of tool angles, how the tool angles can be selected, and what is the significance of the rake angle, flank angle, particularly in the force consumption and power consumption and the force. All right. Next, we discussed the angles, each of these angles in details, including the nose radius. And what is the nose radius, the importance of the nose radius, what is the recommended value, what happens if the nose radius is less or more, all those aspects we have discussed in the lectures. Next, in turning operation, we have we have discussed the forces in machining, what kind of forces are involved there, and how these forces are related with the angles, with the tool angles. Okay. And the first relationship, uh, the angle and the force relationship is given by the Marchant and Ernst, and therefore we discussed the Marchant's theory in great details. And finally, we said that this is related with a very simple equation, which is 2 phi plus lambda minus alpha is equal to 90 degree, pi by 2. Now, we also said that although this is the first treatment given to the cutting operation, but this has a disadvantage that it is only valid for the orthogonal cutting. And since we have most of the processes, we have oblique cutting, as I said. So in oblique cutting, the Marchant's relationship will not be applicable. Now, what is applicable will be, I have discussed it later for the oblique cutting, how the Marchant's relationship can be improved so that the Marchant's relationship could be applied to the oblique cutting. Then we discuss the stress strain in chip formation, how they are related, strain rate, and how the shear plane angle can be measured physically as well as theoretically. Okay. Now, we said that physically it's very difficult to do that because it will have errors, and theoretically you can do that, but theoretically you will find that this is the tan phi, which is related to the T1 by T2. This is uncut thickness and cut thickness, chip thickness relationship into cos alpha, the cos of the rake angle divided by 1 minus R1 by T1 by T2 into sine alpha. That's a very simple relationship which shows that how to find out the shear plane angle. And finding out the shear plane angle is very important because our force and the power consumption will depend greatly on the shear plane angle. Okay, later we have shown that shear plane angle, if it changes, what happens? If the rake angle changes, what happens? Because Marchant's diagram explains some of those things. Through the numerical example, I have shown what is the application of the Marchant's theory. Okay, there are 3 examples I have shown. Next, we have discussed a thin zone model, because one of the assumptions of the Marchant's diagram is that it is a thick zone model when the plastic deformation occurs in a thicker zone. So in the Lee and Schaeffer relationship, we have discussed that this is a thin zone model where the principle of determining the relationship between the forces and the angles is different than the Marchant's diagram. Because in case of Marchant's, I said that it is the principle which is used by Marchant's and Ernst is the minimum power consumption during the cutting process. But here in the Lee and Schaeffer, they are assuming that there should be a plastic zone through which the plastic deformation is transferred from the workpiece to the tool, or from the tool to the workpiece. Okay, and through this, a very similar relationship have been determined by Lee and Schaeffer, and that is called the Lee and Schaeffer relationship, which is a little different than the Marchant's diagram. Okay, after that we discuss the friction in metal cutting, how it is different than the normal friction, and why it is different, because there's a lot of force acting, okay, on the 2 bodies. 2 bodies are the tool, cutting tool, and the workpiece material. And when it happens, then the F and N relationship, they do not remain constant. Okay, that means the mu does not remain constant when the force is becoming very high. Okay, and therefore, within the chip tool contact length, the mu can vary. That means in one place where the force is very high, the mu is not constant, and above certain point where the forces are not so high, the mu remains constant. That means which will have the slope, okay, which will determine the slope, which is the mu. That we discussed in great details. And also there was a Zorev's model that we discussed. And Zorev's model, finally, it says that the lambda, that is the friction angle, that depends on the sigma F average, that is the stress, normal stress, average normal stress. Okay. In practical machining operations, we have discussed turning, milling, drilling, okay, and shaping and broaching a little bit. In turning, we have discussed the relationship, geometrical relationship between the width of cut, depth of cut, okay, uncut thickness, feed, and the power consumption, how to find out the power consumption. What is the relationship of the radial force and the friction force? Okay, what is the relationship between the radial force and the thrust force, and so on. Then we found out in turning that how much time it can take to turn certain length. Okay. Similarly, we discussed the similar things in the shaping, in the drilling, okay, in milling, and then also we discussed the forces in all these operations. Okay, turning, shaping, drilling, and milling. And next we have discussed how to measure these forces through the instrument, through the device, which is called the dynamometer. Okay, there are different types of dynamometers which are used for measuring the forces of the axially loaded members, cantilever beam, rings, octagon, okay, and which one can be used, that also I discussed. Next, we came to the tool wear and tool life. In great details, I have discussed the modes of tool failure, mechanisms of tool failure, okay, and how the flank wear grows, flank wear progresses, what is the crater wear, and what is the relationship of the velocity and the tool life through the Taylor's tool life equation. Okay. Next, we discuss the variables affecting the tool life, that is the cutting conditions, tool geometry, tool material, work material, and the cutting fluid. Each of them we discussed in great details. Okay. Next, we discussed probably some numerical examples, and through 3-4 problems, we have shown the application of Taylor's tool life and the other tool life processes, other tool life equations. In the tool work interaction of the lathe, I showed what is the threading, cutoff, facing, tapering, contour, okay, knurling, and so on. What kind of devices are used for holding the workpiece? In boring, in the shaping and planing, all right, in drilling, and milling also. And in various milling processes, I said there are up milling, down milling, depending on the direction of the milling cutter rotation and the feed direction. All right. And what are the advantages and disadvantages of both the down milling and the up milling? Broaching, we discussed what is broaching and how it is done. Then next we came to the abrasive machining processes. Abrasive machining processes we discussed separately because it has a uniqueness of having many of the cutting tools, in the sense that the abrasive wheel containing the hard particles like Al2O3, boron carbide, silicon carbide, each of them can be considered as a cutting tool. So this is a multiple cutting tool, almost infinite number. I mean, should not say infinite, but the number we cannot count. It is beyond our imagination. Okay. So here the material removal is very different than the other processes. Therefore, we discuss this separately. We said what kind of abrasive materials are there, what is the grain size, what is the grade, the structure, okay, bonding materials, and how the grinding wheels are specified. Okay. Mechanics of grinding processes, we discussed how the chip length is decided and what is the average force per grit and why it is important, right? Because if the grinding wheel is very hard and you are actually grinding hard material, you know that there are very rapid wear of the abrasive grains, okay? And that will be glazing, and therefore you need to have the the grains, abrasive grains, which are worn out. And those abrasive grains have to be taken out from the grinding wheel surface. Therefore, the abrasive grains can be taken out only when the average force per grit will be more. How to apply that and how to control that, I have discussed in that equation. Okay. Next, we have discussed, of course, the mechanics of grinding processes in internal grinding, okay, in the cylindrical grinding, and then how the specific energy in grinding is estimated, and wheel wear. What is wheel wear and how the wheel wear takes place, okay. Next, we discussed quickly and in details the oblique cutting. And as I said, that the oblique cutting is different from the other processes, like the when the cutting velocity and the tool edge is perpendicular, because in this case, since the tool is inclined, so there will be an additional force which will be generated, created. And to discuss that additional force and to take into consideration that additional force, we have derived the formula, and we have seen at the end that it is different from the one that merchants for the simplified system has derived. Okay. Next, we discuss the economics of machining, and in economics of machining, we have seen that how the minimum production cost criteria, okay, then maximum then maximum production rate criteria and the maximum profit criteria can be determined. Yeah, I think there I have stopped, and that actually ends the course. Okay. Now, if we have a question, so you can ask through this. Types of chips to be explained again. All right, what exactly? Tell me. Types of chips. There are 3 types of chips, Vinith, I told you.
Yes.
One is the discontinuous chips, right? Now, the discontinuous chips basically, just let me, yeah. Discontinuous chips basically happens when there is a workpiece material which is brittle. All right.
Okay.
This can be explained from the stress strain curve of the brittle material. All right. So if you go through the stress strain curve of the brittle material, you will see that it is a straight line where the mu is constant. After that, it breaks because it's a brittle material. Okay, am I clear, Vinith?
Yes, sir. Yes.
Yeah.
You're
So
audible.
this is a discontinuous chip. Okay.
Yes, sir.
Now the discontinuous chip happens basically, as I said, first of all, the brittle workpiece material, low cutting speed, okay, large feed and depth of cut, small rake angle, and the high tool chip friction. So each point you can actually, I can describe in great details, but which have been described in the lecture also, that why during the large feed and depth of cut, this is understood, why for the large feed. Now, for the small rake angle, for small rake angle, I discussed it in the selection of rake angles, okay? Like if the rake angle is small, then what happens and why discontinuous chip occurs. Next type of chips is the continuous chips. It is the other way around. That means where you have the ductile material, workpiece material, high cutting speed, small feed, large rake angle, sharp cutting edge, low tool chip friction. So these are all opposite to the discontinuous chip conditions. All right. And here also you can actually explain in great details that why it happens because of the high cutting speed, because of the large rake angle. Rake angle I discussed in very details, but the high cutting speed, small feed and depth of cut, these are discussed during the cutting conditions. Okay, when I discuss the cutting speed, feed, and the depth of cut. All right, if you go through that, you will find the reasoning. A very unique situation happens when there is a built-up edge formation. Okay, built-up edge formation occurs within a certain range of cutting speed. Well, now here particularly the material is ductile. Okay, low to medium cutting speed. As I said, with a certain, for example, I give you the example of the mild steel and the high speed steel, which is about 80 to 110 or so. That is the range within which the built-up edge occurs. And when the speed goes beyond 110, for example, the temperature goes more than the temperature of recrystallization, and then the built-up edge vanishes.
Okay.
Okay, so
Yes.
this is the mechanism. Like built-up edge occurs only at a certain range, not always.
Yes.
And that range for different combination of tool and the work material is different. Okay, so
Clear.
these are the three types of tool chips. Chips. Hope it is clear. And
Yes, sir.
anything else you can go through the material. Okay, that would be better.
Yes,
Lecture
sir.
material, and that material will explain. If you have any further question, you can also tell me.
Yes, sir. Thank you very much.
Yeah, you are welcome. Okay, any other questions, participants? I am waiting, so you can ask. Okay, I'll be happy to answer. Yeah, Mr. Somappa, you have any question? Unmute yourself and you can ask.
No, sir, no doubts.
Okay, so in future, okay, just I'm waiting. If you have any doubt in future also, you can speak
Sure,
up.
sir.
Okay, yeah.
Okay, thank you, sir. Thank you.
Yeah. Mr. Joshi, we are still here in the discussion forum. So
Yes, sir.
don't hesitate. You can speak up or you can write. If you have
Definitely,
any
sir.
other, if you have any other question. Okay.
Definitely, sir.
Yeah.
Yes.
So one student,
Yeah.
Mr. Kumar posted when he will get the hall ticket and what are the things he should bring.
Okay.
To the
Okay, so you are the right person to reply to this question.
Sure, sir.
Yeah.
Right, sir. So examination for our course is scheduled on 22nd of March. So tickets will be available by 15th of March. And students should bring hall ticket as well as an admit card issued by the Government of India to the examination.
Yeah, let me add some of the things like
Sure, sir.
you don't have to bring calculator. Calculator using is not allowed because there will be an inbuilt calculator. You must have practiced with that calculator. It was available in the online. So practice a few more times with using that calculator. But I can assure you that you will not face any difficulty in using that, because in the exam also you won't have very big calculations. That's very simple calculations. Let me tell few things about the exam. 100% questions will be MCQ. Okay, select an answer between A, B, C, D, E, maybe. Okay. There are some numerical questions where the answer is also given within one of these A, B, C, D, E. You don't have to work out. You don't have to, work out you have to, but you don't have to write the answer. You have to select the answer. You work it out, get the answer, and that answer will be one of those choices which are given within A, B, C, D, E. Okay, and the calculations will be very simple. Okay, that online calculator will be more than enough for that. I use that online calculator for getting the solution. Okay, and I found that this will not take more than probably 3-4 minutes.
Yes, sir.
Maximum.
So can we
Okay.
end the session now, sir? Because another session we scheduled.
Yeah, 4:30, right.
Right.
Okay, thank you very much.
So,
Is Mr. Murli Mohan, so Murli Krishnan, sorry. He is helping as a technical assistant and he is doing all those setups and all those. And I'm very thankful to him. Okay, thank you for attending the live session. If you have any other question, you please feel free to put it on the forum and I will reply to those. Okay. Okay,
Yes,
thank
sir.
you
Thank
very
you.
much.
Thank you,
you.
sir. Thank you.
thank you, Mr.
Thank you,
Lee.
Murli, sir. Thank you.